In Chapter 1, Section 7, we're going to continue with inequalities from what you learned in previous grades. Now, if you remember, inequalities could be a not equals, a greater than, less than, greater than or equal to, less than or equal to, and then you would also understand that on a number line, if you shade it, you could have possibly an open or closed circle with shading to the right or left. You've already done that, and this is continuing on that. So we're going to start with a solve it problem. Math club members are selling t-shirts for $7.50 each. The goal is to raise $500. They have already raised $337.50. What is the minimum number of t-shirts they must still sell in order to reach their goal? Now, if you would like, spend a couple minutes to solve this on your own however you would like. We are going to write an inequality. Now, what do we know? We want to know how many t-shirts. So that means if the t-shirts cost $7.50 each, we would write $7.50 per t-shirt, so that'd be 7.5 or $7.50 X. Now, they've already raised how much? They've already raised the $337.50. Now, they have to raise what? They have to raise at least $500. So you have to understand that they don't have to raise exactly $500. They could raise exactly $500 or more. So the inequality that would represent exactly $500 or more, because they have to have at least $500, is greater than or equal to, and then $500. Now, when you solve an inequality, you're going to treat it just like an equation. You're going to follow the same steps to solve as you would an equation. So we're going to subtract $337.50. And that gives you $162.50 or 0.5. And then we have 7.5x left over. Divide both sides by 7.5. And you will get approximately, well, 21.7, or it's 21 2/3, 21 6/10 repeating. Now you'll notice you cannot have 21 t-shirts in like an arm or a sleeve. You have to be able to interpret what this means. You have to have the value of X, which is the number of shirts, has to be greater than this number. So how many whole shirts would we start at that's greater than this number? Well, it'd be 22. So in words, explain what it means. How many t-shirts must they sell? What's the minimum number? The minimum number of t-shirts will be 22 t-shirts. Now, could they sell 25 t-shirts? Absolutely. They could sell 50 t-shirts, but there has to be 22 or more t-shirts. But since this question asks what is the minimum number, we can write 22 t-shirts. Here are two examples that we're going to do under problem 1 under the Got It section on page 60. What are the solutions of the inequality? So we're going to solve these like normal equations. First, we're going to add 7 to both sides on A, negative 6A. Minus 7 is less than or equal to 17. So we add 7. And we divide by negative 6. Now, something you should remember from last year. When you divide by or multiply by a negative, what happens to that inequality? It flips. So make sure that's a key concept that you don't forget. When you divide by a negative, it has nothing to do with the number you're dividing into. When you divide or multiply by a negative, this inequality flips. So our answer in this problem would be A is greater than or equal to negative 4. In the second inequality, we have negative 4 is less than 5 minus 3m. So since the variable is already on one side, we're just going to subtract 5. That gives us negative 9 is less than negative 3n. I divide by negative 3. That gives me 3. Now, because I divided by a negative, this inequality of less than is going to flip. And my answer is going to be 3 is greater than n. Or you have to realize that is also the same thing as n is less than 3. So either one of these would be an acceptable answer. 3 is greater than n, or n is less than 3. Let's look at the problem number 2, the got it problem, where it says writing and solving a multi-step inequality. It says you want to make a rectangular banner that is 18 feet long with a trim that goes around the entire border of the banner. You have no more than 48 feet of trim for the banner. What are the possible widths for this banner? So the first thing I'm going to do is I'm just going to kind of draw a rough rectangle here. We know that we have a rectangular banner and that it's 18 feet long. So I'm going to label the length as 18 feet. So that means this is also going to be 18 feet. We have no more than 48 feet of trim for the banner. So the trim is going to be the border of this banner. So the border is here, which means we're talking about perimeter. So what do we know about perimeter? We know to find perimeter, we have to add up all the sides. So we want to know what are the possible widths. Well, if we don't know the widths, I'm just going to put an X there. So if I find the perimeter here, that would give me 2x plus 36. Now I want no more than 48 feet, so you got to just be able to interpret this. Could you have exactly 48 feet of trim? Yeah, but we can't have more than that. So you can have exactly 48 feet or less. So the inequality I need is less than or equal to, because your length of trim can't go over that 48. So now you solve this. Subtract 36. So 48 minus 36 is 12. Divide by 2. X is less than or equal to 6. And this is the part that you've got to get good at. Interpret what your answer means. The question asks, what are the possible widths? Well, the value of x, which is our width, has to be less than or equal to 6. So the width must be 6 feet or less. Because if you just tell me 6 feet, you're telling me that is the only answer. You could have 5 feet, 4 feet, 3 feet. You just cannot go over 6. So you have to, in your answer, tell me all the possible solutions. So it would be 6 feet or less of trim. Now we are going to be doing problem number 3 on the bottom of page 62. We're now going to be using the distributive property. Once again, you're going to solve this as you would a normal equation. So let's look at the got it problem. In this problem, we're going to first distribute. So we have to distribute a negative 2. If you distribute a negative 2, you are going to get negative 2 times 4m, which is negative 8m, and negative 2 times 7, which is negative 14. I now am going to combine like terms, so I'm going to combine the 5 and the negative 14. So the negative 8m comes down, and 5 minus 14 would give me negative 9. I now add 9 to both sides. That would give me 24 is less than or equal to negative 8m. I divide by negative 8. So my answer would be negative 3 is greater than or equal to m. I switch the inequality because I divided by a negative. And so my answer would be negative 3 is greater than or equal to m. Or you could write it as m is less than or equal to negative 3. So I want you to do practice A, number 5, by yourself. And if you did it correctly, number 5 would give you an answer of j is less than negative 1. You should have distributed the negative 3 and got negative 3j minus 9 plus 9j is less than negative 15. Combine negative 3j plus 9j, got 6j minus 9 is less than negative 15. Added 9 on both sides. 6j is less than negative 6. Divide by 6, you get j is less than negative 1. Now why wouldn't the inequality have switched there? Because we have a negative 6 right here. Why would you have not switched the sign? Because the number you're dividing by was not negative. Therefore, the inequality does not switch. We are now going to do problem number 4, which have variable on both sides. Once again, this is just review because you've done equations with this, so this should not be very hard. So let's just do one problem. 3b plus 12 is greater than 27 minus 2b. This is the got it problem, A. So the first thing I need to do is get the variable on one side. So I'm going to add 2b to both sides. That would give me 5b plus 12 is greater than 27. I now subtract 12 on both sides. I get 5b is greater than 15. I divide by 5. My answer would be b is greater than 3. Now we are going to start something new. If you look at the gray box on page 64, it says, sometimes solving an inequality gives a statement that is always true, such as 4 is greater than 1. I want you to circle that and underline always true. 4 is greater than 1. In that case, the solutions are all real numbers. Underline all real numbers. So if an inequality is always true, because the variables canceled out, your answer is all real numbers. If the statement is never true, underline that, such as 9 is less than or equal to negative 5, that's not true, the inequality has no solution. This is your key concept today. So put a star next to it, underline it, but make sure you study this part. This is what I'm going to be asking you tomorrow for the pop quiz. I'm going to be asking you to identify how you know something is all real numbers or no solution. So let's do A. Variables on both sides, so the first thing I want to do is subtract 5n. If you subtract 5n on both sides, that's going to be left with 9 is less than or equal to negative 1. So you have to ask yourself, is that a true statement? Is 9 less than or equal to negative 1? No, it's not. Therefore, this is not true. Therefore, your answer is no solution. So now let's look at problem B. Problem B, we're going to first combine like terms. We have 8 plus 6x is greater than or equal to 7x plus 2 minus x. So that would give me 8 plus 6x. 7x minus 1x gives me 6x plus 2. If I subtract the 6x's on both sides, they're going to cancel. So I am left with 8 is greater than 2. Is 8 going to be greater than 2 or equal to 2? Yes, it's always going to be true. Therefore, this answer is all real numbers. So I want you to do practice A, numbers 9 and 10 on your own. Now number 9, you first would distribute the negative 5, and then both negative 5r's cancel when you add 5r to both sides. And your answer on number 9 would give you all real numbers. On number 10, you would distribute the 2, combine like terms, subtract 2x on both sides, and they would cancel, and what you're left with would never be true, and therefore your answer would be no solution. So your key concepts today are to know that if you get something that is always true, if the variables cancel and the inequality that's left is true, your answer is all real numbers. If it is never true, you get an inequality that is not true, then the inequality has no solution.